All right, Algebros. We are going to be talking about example 4 and 5, and we're going to be putting together all the information that you have discussed either in this class or in Algebra 1. We're bringing it all together. So domain, if you don't remember, domain is the x values. Oops, writing with the erasers, not the best. The x values where the graph exists, and the range is the y values where the graph exists. Okay, so if we look here at this graph is going to continue to get wider and wider forever. Nothing's going to stop it from hitting every single x value along the way. So the domain includes all real numbers. Or you can use this fancy symbol where it's almost like the paragraph sign, but it's an R. That stands for all real numbers. The range, the y values. So again, we're looking for the y values, and we're looking to where this graph exists up and down. Well, nothing's stopping this graph as it gets lower, and nothing's stopping this graph as it gets higher. So it's including all real numbers for the range as well. And again, you can use that symbol. Right, from our lesson today, what are the increasing intervals? So remember, we're going to hop on our little roller coaster, and we start at the left. So we're click, 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 up from negative infinity to negative 1. So when x is less than negative 1, less than or equal to negative 1, we're increasing. Once we get to negative 1, we're going wee, and we decrease to positive 1. So from negative 1 to positive 1, we are decreasing. And then from positive 1, we're going back up again. So we're increasing again from positive 1 to infinity. Our end behavior. On the left side of our graph, as our x values get smaller, so as our x values go towards negative infinity, our y values also go towards negative infinity. So as x approaches negative infinity, y approaches negative infinity. And to the right side of the graph, our end behavior, as our x values get bigger, our y values get bigger. So as x approaches positive infinity, y approaches positive infinity as well. Our y-intercept, remember our y-intercept is where we cross the y-axis, is, we got to look at our scale. Our scale is going by 2s, 2, 4, 6, 8, so 2, at positive 2. So I would prefer it written as an ordered pair, but if you just write 2, I guess that's all right too. A cubic function, which is what this graph is, does not have an absolute maximum or an absolute minimum. Why? Because this graph is continuing to go on forever, and it's never going to stop at a certain spot. So there is no absolute max or absolute min, but there is a relative maximum and minimum. And that is where our graph makes a little hill and where it makes a little valley. So our relative maximum is at negative 1, 4, the ordered pair. Our relative minimum is where we create a valley, and it's at positive 1, 0. To evaluate a function at a given value, so f of 2, so we want the x value of 2. So at an x value of 2, our graph equals 4. At an x value of negative 1, our graph also equals 4. And our x-intercepts, looks like we cross at negative 2 and at positive 1. So again, I'd prefer ordered pairs. But if you just wrote -2 and 1, that's all right too. All right, let's take a look at number 5. So the domain, again, the x values where this graph exists. So this graph's going to continue to get wider forever and ever. There's nothing going to stop it from hitting every x value along the way. So again, our domain is going to be all real numbers. And you can also use that symbol, and then you don't have to write it out. But our range, you can see the graph stops here, and it does not exist below that point. So all the y values below -2 are not included in the range because the graph doesn't exist there. The graph only exists above -2. So our range includes all the numbers that are greater than -2. So the y values that are greater than or equal to -2 would be the range. All right, now let's figure out what our increasing intervals are. So again, we're going to hop on our roller coaster on the left side of our graph, and we're going down all the way to an x value of 0. So we're decreasing from -infinity to 0. So all the values that are less than 0. And then at 0, we change directions and we go up for infinity. So our increasing intervals are 0 to infinity. So we want our x value to be the big number in our increasing because it's going to the big numbers. And in our decreasing, we want the x to be the small value because it's getting smaller. Our end behavior, as our x values are getting smaller, our y values are getting bigger. So as x approaches -infinity, y approaches positive infinity. And as our x values get bigger, so as x approaches positive infinity, our y values are also getting bigger. So y will also be approaching positive infinity. Our y-intercept is -2. Again, I would prefer it as an ordered pair, but if you just wrote -2, that's all right. So for what values of x does f of x equal -1? So f of x represents y. So when the y value is -1, our x value is +1 and -1. This graph does not have an absolute maximum, but it does have an absolute minimum. The lowest point that this graph will reach is -2, and that would be 0, -2. All right, so we are just diving into all different pieces of graphs. So happy mathing to you, and you have an assignment today that'll look a lot like example 4 and 5, and then you also have a quick quizzes to do just for some more practice.